Everything know the word, so grand. Earth, crafting life for all, your gifts expand.
Earth, the core of existence, breathe with grace. Earth, provider of life for every plant, a place.
Hello, my name is Shalita Suphanachat.
Hello, my name is Chavisara Singtra.
Hello, my name is Pongsuthorn Chaisain.
Hello, my name is Shutikan Walaratgun.
Hello, my name is Emily Kantisha Van Steenberg.
We are from Bari Chiang Mai School. All research is a comparison of how coffee ground and biochar affect soil fertility for growing Chinese Convolvulus. Rationale: soil is crucial for the growth of plant and agriculture. Plants rely on soil for root accurate, water retention, air supply, and nutrients necessary for growth and productivity. If the soil is fertile, it positively impacts the growth of plants and increases yield for farmers. Currently, the soil in the local area exhibit physical and chemical properties that are not suitable or less suitable for cultivation, causing plants to grow and produce yield below normal level. This is primarily due for naturally occurring soil types such as saline soil, soil excessively acidic soil, and soil deficient in organic matter. These conditions can severely impact the ecosystem and the environment. If these soils are to be used for crop cultivation, it is necessary to improve the soil before planting. The use of organic material in agriculture to improve soil have physical and chemical implications for soil fertility. Plants can utilize this material for growth. Typically, farmers use organic material such as biochar to amend soil before planting. It is also often used as a planting medium made with soil for continued gardening. At V Cafe in Vari Chiang Mai School, there is a large quantity of coffee grounds generated as waste from the coffee extraction process. Therefore, we were interested in utilizing coffee grounds as organic material in agriculture to improve soil before planting. We conducted a comparative study on the effects of different ratios of coffee grounds and biochar on soil fertility for the growth of Chinese Convolvulus. It was expected that the results would promote efficient and highly effective resource utilization. Objective 1. To study and compare the effects of different ratio of coffee ground and biochar on soil facility. 2. To study and compare the effects of different ratio of coffee ground and biochar on the ground of Chinese Convolvulus. 3. To disseminate the comparative study finding as agricultural data for the school and community. Question: do different ratio of coffee ground and biochar affect soil fertility and the growth of Chinese Convolvulus? Is so how? Hypothesis: different ratio of coffee ground and biochar heavily affect on soil fertility and the growth of Chinese Convolvulus material and equipment. 1. Chinese Convolvulus seeds. 2. 7 experimental plot. 3. Pointed travel. 4. Classification by touch field guide, soil structure handbook. 5. Soil color comparison book. 6. In-house air temperature and soil moisture sensor. 7. Measuring tools such as a ruler, vernier caliper, and weighing scale. 8. Soil testing kit for pH, nitrogen, phosphorus, and potassium values. Methodologies. 1. Prepare 7 experimental plot measuring 0.5 meters times 1 meters. 2. Prepare coffee ground and biochar mixed into the soil for experimental plot. 2 to 7 according to the specified ratios of 5%, 10%, 15% respectively. 3. Create equipment for measuring air temperature, air humidity, soil temperature, and soil moisture using ESP32 NOD MCU, ESP32 Wi-Fi, Bluetooth board, and virus sensor. Program the device record data for 1 hour to collect information for analyzing the differences in temperature and soil moisture within the experimental plot. 4. Collect oil sample and measure the physical and chemical property of the soil such as soil pH value and the level of nitrogen, phosphorus, and potassium before planting. 5. Sow Chinese Convolvulus seeds in the experimental plot with its pods. Receiving 115 seeds, record the growth of the Chinese Convolvulus over 4 weeks, including height and stem circumference in tools such as a vernier caliper. 6. Enter the corrupted data into the probe data entry in system and analyze and compare it with other data. 7. Collect biomass data by measuring the fresh weight of the plants, analyze the data, summarize the findings, and provide discussion. Everyone had a role in conducting the research from step 1 to 7, collaborating willingly and receiving guidance consultation from Ms. Ratanaporn Vatpet, the research advisor, a science expert providing knowledge on measuring the physical and chemical fertility of soil, and Ms. Kuntali Panin, a social study and geographic expert providing knowledge on local environmental improvement and development. I have learned from working on this study that collaboration contributes to success.
Thank you everyone for their assistance. Together, we have the strength to move towards success.
Everyone was responsible for their task. We worked together harmoniously. We help, push, and support each other.
Having engaged in research work led to acquiring various knowledge and enhanced STEM skills, which includes science, technology, engineering, and mathematics. For example, we invent equipment to measure soil temperature and moisture using ESP32 board with inborn coding command to collect accurate data.
Everyone had a clear workflow, knew their responsibilities, and performed their tasks. Working as a team allowed us to have diverse perspectives that could be utilized for further improvement. Additionally, everyone actively contributed to generating ideas and seeking the best solutions.
The soil structure was in form of round clump, dark brown in color and loamy in texture across all 7 pots, showing no significant variation. Using temperature sensor equipment, the lowest average air temperature record was 25 degrees Celsius, absorbed in the pot with 10% coffee ground, while the highest average moisture content was 36 degrees Celsius, absorbed in the pot with 15% coffee ground. The pH level was critic with a pH of 4 in the soil pot and pH 5 in both the 10% coffee ground pot and the biochar pot. The quantity of nitrogen, phosphorus, and potassium in the soil were all low. In the coffee ground pot, nitrogen was low, phosphorus was high, and potassium is moderate. In biochar pot, nitrogen was low, phosphorus was moderate, and potassium was high. The growth of Chinese Convolvulus was measured in terms of height and stem circumference. The pot with 10% biochar inhibits the base growth.
Conclusion and discussion. It was found that the optimal mixtures of coffee grounds and biochar contributes to the chemical fertility of the soil, resulting in increased nutrient levels in the soil. Specifically, the soil mixed with coffee grounds show higher phosphorus levels, while the soil mixed with biochar exhibit higher potassium levels. This has implications for plant growth. When measuring the fresh weight of Chinese Convolvulus grown in different plots, it was observed that the plot with 10% biochar and the plot with 5% coffee grounds had the same fresh weight, which was 0.40 kilograms, the highest among all plots. Therefore, the appropriate ratio of coffee grounds and biochar may serve as an alternative organic material for farmers to amend and nourish the soil before planting, thereby promoting plant growth and increasing agricultural yields.
From the study, we communicate agriculture knowledge within the school and community by creating brochure and summary video of research findings. This material serves as guidelines for farmers to use in amending and nourishing the soil before planting, thereby promoting plant growth, increasing agriculture yields, and potentially reducing cultivation costs through the use of coffee ground. We hope that our research will serve as a guideline